All right, today we're looking at section 2.1, which is about atomic theory. And this theory, proposed over time, didn't develop all at once. So we're going to do a brief historical overview and then talk about which parts we still have valid reason to think are accurate. Start with Dalton, who's a scientist. The exact date forgets me, but he made these 5 propositions: that matter is made of atoms, that atoms of the same element are identical, they're not made or destroyed, they exist because there's a universe. Atoms build larger molecules in chemical reactions, rearrange atoms. And most of these are pretty accurate. He was spot on the nose in his early experiments and his thinking about how atoms behave, how the subunits of matter behave. Our next theory came from scientist Thomson, and he said that the electron is negatively charged. We won't get into here about how he did that. And Rutherford, let's see if I can move myself out of the way, so the mass of the atom is almost entirely in the nucleus. He had a really neat experiment where he was able to fire charged particles through a thin sheet of gold, and and if an atom was like universally, like all the mass was spread throughout, like at the top here, then the atom should go one direction. But if we found here was on the bottom, where most of the particles went straight forward. Some were deflected to the side, and some were deflected backwards, which to him meant most of this atom must be empty space because most of these charged particles are going straight ahead. You see what I'm getting at? So if the top was a prevailing model of an atom, is a big positively charged sphere with little electrons embedded, like it's called like the raisin pudding model, right? Because the electrons were embedded in this great big pudding of positive charge. Rutherford says no, that's not the case. So it was, we'd expect charged particles to go straight through, not be deflected, but he says, hey, there's deflection. That means most of it's empty space. So this is a huge step in the development of our atomic model. Then Niels Bohr, who was one of the great scientists of the 20th century, realized, hey, electrons orbit the nucleus. They have definite energy levels. See, as the electron, the little blue spinning thing, jumps from inner to the outer. We'll get back to why it's doing that with releasing energy another day. But the point being, Niels Bohr said, hey, electrons orbit nucleus at definite energy levels. Chadwick determined, hey, the nucleus contains protons and neutrons. In summary, let me get out of the way again. If I can grab my screen. There we go. In summary, so matter is made of atoms. Dalton's right in that. Atoms of the same element are identical. Mostly, we'll get back to the exceptions in a minute in the next video. Atoms form larger molecules. Dalton was spot on with that idea. And chemical reactions rearrange atoms. Additionally, electrons orbit the nucleus with a negative charge. Neutrons have no charge. And neutrons and protons are in the nucleus. All right, so that kind of does it for the development of atomic theory. It's important these are models, help us understand what an atom is. It's being revised. We learn more and more about it, especially about subatomic particles that make up protons and neutrons and electrons, and the whole sea of weirdness that happens when you get to those level of particles. But for now, this is a model we're going to work with the protons and neutrons in the middle, in the nucleus, which represents a teeny tiny little point of space. If an atom was the size of a stadium, the nucleus would be like the football on the 50-yard line, right? That would be it. The electrons would be in the nosebleed section. That's how much empty space our models say are in a single atom. All right. So that does it for this recording, and I'll see you guys either in the next video or in class. Please see me if you have any questions. A lot of information on this. I'll post the slides here with the summaries in the review part of the section. All right.